Swayam Prabha. Digital India. Educated India.
Dear students, we are back to the class of geometric design. Today again we are going to discuss about the various factors. Before going into the new factors, let us talk about that what we have discussed in the previous interaction. In the previous interaction, we started with the factors related to road systems and we talked about the traffic volume, wherein different terminologies have been looked at. Then we talked about the traffic composition, where we looked at the static and the dynamic PCU values, so that the traffic can become homogenized in terms of the passenger cars in an urban area. We then talked about the design period and the growth rate, and the next which we discussed was the design speed under different conditions of roads or categorizations, that means urban roads, the rural highways, multi-lane roads or the expressways. And then finally, we talked about the capacity. With this information in hand, let us move ahead and see that what are the other factors which are further going to make a difference in terms of the design of facilities or the provision or implementation of those facilities. So, the factors which we are going to talk today, they are being listed here. What you can see is the very first factor is the level of service, which is related again with the road aspects, and then after that we are going to talk about further different factors which in the very starting I have categorized under the external factors, and they are topography, funds, safety and political thought process. So, these are the things we are going to look at. So, let us start with the factors here, but before that, because towards the end in the previous lecture we were talking about capacity, and in that capacity we said that the capacity is nothing but 1000 into V divided by S. It will be good if we look at one of the example or two of the example in that case. So, here one example is being given where it is being defined that the traffic is moving at a speed of 48 kilometers per hour. All vehicles are passenger cars and they have a length as 5 meters on an average. Vehicles are moving while maintaining a clear average distance of 48 meters. Now, we have to calculate the capacity of a traffic lane. So, this is V and this is S, which is being given to us, and if we put these values in the formula, what we get is 1000 vehicles per hour per lane. And if this road is having 2 lanes on the carriageway, then the capacity of the road is nothing but it is the multiplication of 1000 with 2, that means 2000 vehicles per hour is going to be the capacity in this case. Let us look at another example here, where again the speed is being given as 65 kilometers per hour. So, this is V. All vehicles are again being defined as passenger cars with a length on an average of 6 meters, and we have to calculate the capacity of the traffic lane. So, no information has been given in terms of S. For that S, which is average spacing, the formula is 0.2 times of V plus L, and when we use this, what we get is 19 meters, and if we use this value in the formula, what we are going to get is 3421 vehicles per hour per lane, which is going to be a very excessive value in this case, which can be handled by this particular lane. But we are not going into the details of that at the moment. What we have tried to see that how these values can be calculated. Now, when you are calculating these values, and we have seen in 2 of the photographs, in one photograph the vehicles were moving but distances being maintained between them. In another photograph we have seen in the urban area in the previous lecture, where all of those vehicles were very close to each other and there were multiple lanes. That means the system, the road system which we are talking here particularly, is not working in the desired conditions in one case, but it is working in the desired condition in the other case, and that is where it is being defined in terms of the level of service. Now, when you are looking at this level of service, then this defines the ease and convenience with which the users or the vehicles are going to move or use the facility. and this level of service is being used as a pointer for our performance analysis. Most of the time these are being defined in 6 categories, we moves to A to F, where the category A defines the highest level and category F defines the lowest level of comfort or ease or driving or speeds or whatever we consider here as a factor. In most of the cases, when we are talking about the facilities in urban areas or in rural highways conditions, we are sticking to LOS B or C. In urban areas, we try to go up to C, and in the rural highways conditions or multi-lane highway condition, we try to get LOS B, and if LOS B is already reached, that means now it is the time when the facility needs to be enhanced in size. The various attributes are used to define LOS, and the most important ones which are mostly being used, they are either the flow or volume or speed or density, but there are others which are there which are like delay, the number of vehicles following. So, you are moving in your vehicle and how many vehicles are following you because of the constraints, because they cannot move ahead of you. The travel time saved. In terms of pedestrians, one another thing which is being considered is the space per pedestrian. So, when you are looking at these, the list is going to be a bit more, but it all depends on what type of facility you are talking and who are the users who are going to use that facility. Accordingly, these attributes are going to change. But we are not going into the details for those at the moment, because that is not a scope here, but we need to understand that when you are trying to design a facility, we try to see that the LOS either B or C is being there in which the facility is working or operational. Now, when you look at this level of service, and I said that it is changing from A to F, where A is the highest one and F is the lowest one, there is a differentiation between these, and that is on the basis of the flow conditions, on the basis of the speeds, on the basis of the side frictions, on the basis of the driver's discomfort. So, all of these things are going to define, and that is what is being listed here. So, if we look at LOS A, that defines a free flow condition. That means all of the vehicles which are moving on a road, they are moving at a desired speed, there is no interaction as such between the vehicles and they are free to move. So, here the speeds are being considered as 90% of the free flow speed. So, that is a range we are trying to talk here. The side frictions, because the vehicles are moving, maintaining quite a gap longitudinally as well as in the transverse direction. So, those frictions are very low, and that creates a good comfort and convenience in that case. So, A is going to be the best thing to be there, but if you have to provide this A, then the size of the facility is going to be very, very big, and that is where different other factors which we are going to talk in today's interaction plays a role, and that is the reason why we talk about LOS B or LOS C, so as to be provided under operational conditions on any road. When you talk about LOS B, then we talk about 70% of the free flow speed, and this is being defined as the zone of stable flow. Side frictions starts playing their role, and that causes some relatively lower conditions in terms of comfort and convenience. Then LOS C is there, which is again a zone of stable flow. So, means up to this point we are having a stable condition, that is what we are talking. The travel speed is going to be 50% of the free flow speed, that is the range we are looking at. Side frictions are going to affect the drivers. Level of comfort and convenience is now starting declining because the speeds have become lesser and more of an interaction are going to be there between the vehicles. When we look at LOS D, then LOS D is the limit of the stable flow. Okay, so, before we were talking about the zone of stable flow, the average speeds are further less to 40%. Side frictions are going to create a lot of effect, and this convenience and comfort is going to become quite poor here. When you look at LOS E, then when we are very close to the capacity level, and in this case when you talk about the capacity, so this is the capacity level which is there. If you talk here only in terms of Q, so this is Q maximum, but what is being shown here is a volume to capacity ratio. That means, whatever is the traffic moving on a road and what is the maximum traffic which can be handled by that road is what we are looking at, and obviously this cannot be more than 1.0. So, it has to be less than or equals to 1.0 at the maximum. So, that is where this factor here, if we are talking in terms of ratio, is 1.0. So, when you are talking about this LOSE, then here the speeds are going to be roughly around 1/3 of the free flow speed. Side frictions are going to be enormous, and it will cause the forced maneuvers, and the comfort and convenience, this is going to be extremely poor, and drivers will start experiencing the frustration while driving. And LOSF is the zone of forced or breakdown flow. So, this is the most congested condition which is going to be there. So, that is where, as I said, that we are trying to work in this domain, but if it has come in this domain, it is still acceptable in a sense that the system will keep working up to certain extent with respect to the driver's comfort, but if you are going below that, then this is actually not acceptable at all. So, this forced or breakdown flow which is there, it will cause the formation of queues, the delays will be there, the movements will be stop and go movements, the average speeds will be in a range of 25 to 33% of the free flow speed. So, that is what usually we are going to talk in this form. But when you are looking at these values of the speeds which we have talked here, that values may change when you look at an urban road or when you look at a rural highway, and these rural highways nowadays they are being talked as inter-urban roads or highways. So, this is a new terminology which nowadays we are working with, and accordingly you will find that in the urban areas these values which have been defined here as 1/3, 40%, 25%, they are further being taken lesser than these values. But yes, that is going to be a point of discussion when we have to look at level of surface further in more details. Now, the next factor which we are looking is topography. You must have noticed that when I was talking about the design speeds, I said there is a plain terrain, rolling terrain, mountainous terrain, steep terrain, and the combination of these terrains as plain and rolling, mountainous and steep, and mountainous and steep taken together, hilly, all those things were talked. Actually, this is nothing but this is being defined in terms of the cross slope of the ground. So, when you are moving in a particular direction at 90° to that, whatever is the slope of the terrain of that area is what is defining here the topography. And as I said that there are 4 classifications, and these 4 classifications are based on the values of the cross slopes. So, if it is less than or equals to 10%, it is defined as plain. If it is 10 to 25, defined as rolling. If it is 25 to 60%, then it is defined as mountainous, and if it is more than 60%, then we say it is a steep terrain. So, what you can see is that as these values are increasing, the terrain conditions are being defined here in that form. So, this is a schematic diagram by which you can understand, and your movement is going to be in this form. So, if you are within the plain terrain, it means everything is more comfortable, but when you are in a steep terrain, then you will find the ups and downs which are going to be there. So, that is what is happening. As the value is increasing, you are going into a more rugged condition, and you have to face various types of frictions in terms of your traction, in terms of your steering, etc. There is another way of classifying the topography, and that is based on the rise and fall, which is taken in terms of meters per kilometer, or the degree of curvature, which is taken in terms of degree per kilometer. Now, here you can see that there are 3 classifications are being talked here, where hilly means it is talking about mountainous and steep together. So, we have plain, rolling and hilly, and then within plain, rolling and hilly we have low and high curvature conditions. So, we found that the values which have been defined in terms of a rise and fall and meter per kilometer, if it is from 0 to 15, then we are in the plain terrain. If it is from 16 to 30, then it is a rolling, and if it is more than 30, then it is a hilly terrain. But when you are looking at the curvature, then the curvature is being defined in terms of 0 to 50 and more than 50 for plain, 0 to 100 and more than 100 for rolling, and 0 to 200 and more than 200 for hilly terrain. So, this is how the combinations are going to be there, and if the data is available to you, then you can find it out that what are these values, and accordingly you can classify that area in terms of a terrain. So, here you can see that there are different photographs being shown to you. In the first photograph which is there, you can find that there are many curvatures which are coming. At the same time, this is going slowly up. So, there is a gradual rise with lot of curvature. Okay. So, that is one case. The case 2, there is no curvature, it is a straight section, but what you found is the steep gradient is going to be there. It means a rise and fall which is going to be there when you move either from this direction or from this direction is quite high. If you look at the diagram 3 or this photograph 3, then again the serpentine road is there. So, it means the curvatures are going to be there, and if it is happening all along the face of a hill, then the rise is also going to be there, and depending on the way it is moving, there can also be a fall. So, that is another condition. Then if you look at the fourth one, it looks like to be in a hilly area, but there is no rise, but the curvatures are there. So, we need to understand in that manner. Here if you look at the fifth one, what you found is that slowly the rise is there along with the curvature. The amount of curvature is almost like you are just changing your direction by 180 degrees at this particular location. Similarly, here also all these are 180 degrees turns. And if you look at the sixth one, the curvature is probably not there, it is a straight section, but with lot of rise and falls. So, when you start looking at this information, you have taken the information for 1 kilometer or more kilometers and then compute it as on an average for 1 kilometer, you will get the classification. So, here you can look at this classification which is there. So, let us look at this example where there is a 10 kilometer long road. We do not know what is the terrain, the information is being given here. It says that for the particular chainage changing from 0 to 10 kilometers, we have different curvatures at different values of the chainage, and then RLs are also being given. So, they are going plus and minus in that. So, what we are doing is we are looking at the sum of the curvature with respect to the 10 kilometers, and what we get is 8.6 degrees per kilometer. Similarly, when we compute the rise and fall, so initially this is a rise, then this is a fall, then this is a rise, then this is a rise, then this also is rise, and this is also a rise. So, if we compute all of this with positives and negatives, what we get is 40 divided by 10, and this is 4 meters per kilometer. So, with these two values we found that this is nothing but it is a plain terrain with low curvature. So, this is how we can find it out if these values are available to you. Now, the another factor which is there, as I said, that you should always try to provide for LOS A, but then if you are doing it, then you are going to have a very big size of a facility, and that should not be there, because you may or may not have funds, and that is where the funds is a very important aspect, because these funds are going to flow from the government agencies. So, you have to bid for it, you have to put the estimates that this is the type of facility you want to create, and this is the estimate of the quantities and the money which is required, and finally, the approvals will come from the top depending on whether the funds are available or not. And because you are looking at the facility which is to be designed for the 10 to 20th year, this size is going to increase. So, when this expenditure is quite high, we need to see that from where this money is going to come. Now, authorities, if they do not have the sufficient amount in their pocket at the moment when you are going to place your estimate to them, then you have to see that what can be the options with which you can get the approvals from the higher authorities. So, in that direction, what you have to look at the options which are available. Now, one option can be a stage construction. Now, stage construction means you are going to provide a facility which is a multi-lane facility, and there are going to be number of lanes, say the 3 lanes on one side and the 3 lanes on the other side, but you do not have money to construct this big size of a facility. So, can we do it that today the requirement is not for 6 lanes, it may be probably for only 2 lanes or 3 lanes. So, can we construct one side in an eccentric form, and tomorrow After 5th year or 10th year, we can go ahead with the construction of the another side, and that is how the whole facility can be there in place at that location, and that is sort of a condition if we are doing can be defined maybe as a stage construction. So, this is one way of a stage construction. Another way of a stage construction can be in terms of the thickness of pavement, that is the carriageway which is being provided. So, instead of talking in terms of width, we can also talk in terms of thickness, but this is the one thing which we can talk when we are talking about the pavement designs and all, but these are the two options of a stage constructions which can be there. The another option can be that we can call as a government agency the private companies who are having the money in their pocket, and we ask them to construct and then if possible to operate also the facility which they have constructed. So, sometimes it can be only for construction, sometimes it is for construction and operation, and sometimes it can even be for maintenance, depending on what are the various types of modules which may be there, and these modules are being talked as PPP mode, that is public private partnership, which is going to be there. So, here the government is not putting their own money, they are getting the money from some other agency, and it is helping them in a sense that the facility is there, and whatever money they had they have used in different other sectors for the other upliftments, health systems, etc., which are required for the population which is there in a particular area. Next option can be that you go for the financial assistance from World Bank, Asian Development Bank, or any such lender who can give you some money. But the issues here are that they are going to give you this money on a certain interest. So, this interest rate which is there on your borrowing, you have to pay them back, and when you try to pay them back, then you should have the money in your pocket to pay them back also, otherwise you are going to be in the debts. So, the one thing which is try to look at when you are going with these type of projects where the external fundings are there, we look at the IRR, that is internal rate of return, and try to see that if this IRR is greater than the rate of interest, then this particular system is going to be beneficial. Now, economic aspects when you are looking at this IRR are also being looked at in terms of the various benefits, say the travel time savings, the increase in the travel speed, all of these things. So, if you go into the IRR calculation, then you are going to look at these aspects. So, what are the before condition, what are the after condition when these facilities have been provided in that area. Another factor is safety. Safety is to be ensured. You are going to provide a facility for the different type of road users, and when you talk about these different type of road users, they are pedestrians, they are non-motorized, they are motorized, and when the interactions are there between all of them on the same carriageway, then this is going to be a big problem in terms of a hazardous situations which may get created now and then. The another factor is that all of these vehicles which are moving at a higher speed on a facility, if they go out of control, then the property on the roadside is also going to face the problems. So, this is another aspect we have to see. That means, when you are trying to design, you need to embed the safety features, and when we say safety features, these can be in terms of devices, etc. So, when we are looking at these safeties can also be accomplished by way of providing the various signs, signals, markings, etc., which are a part of a road furniture. So, as I said, there can be safety devices, there are road furnitures which can be used so as to improve upon the safety. The safety can also be through the design of a facility. You are providing a road, there is a turning, there is a lot of traffic which is taking a right turn or a left turn, and if you have not segregated them, then you will find that the people are taking the wayward movements are there, and there is going to be again a hazardous situation, or otherwise it is not there, then there can be the unpleasant situation in terms of brawls on the roadside. So, we need to look at what are the various features in the physical form which can be embedded in our design, and say one thing can be channelization. If you are talking about a multi-lane divided system, you have a median in between which is segregating the traffic. So, that is can be, this is a one way of looking at it. We need to look at how many access points are there on a road facility, or can we close those access points. You must have seen in your urban areas or urban roads, sometimes there is a gap in the median, but then the police closes that gap and ask you to take a turn at some other location, because there has been observed to be lot many accidents taking place, or it was creating a hindrance to the main traffic which is moving on a main carriageway. So, we are going to have different such type of features in the design in terms of a cross sectional elements too, which we will be discussing in the next module, and that can be brought in into the design to make the thing safe. Then operational controls can also be there, and these operational controls can be in terms of again devices, markings, speed controls by way of signals, etc. So, these are other features. This is one of a good photograph, or you can say a sketch being created where lot many things have been shown. You can see that there is a barrier on the side, there is a edge marking being provided in terms of the studs, there is a marking on the road which is being provided, which defines that the traffic has to be on the two different lanes. There is again one raised median which is being provided, because the space may not be there to provide the wide medians here. The obstructions, if they are there, they have been defined in terms of cones, in terms of the markings which are there in the yellow and black colors. There is a crossing being provided for pedestrians, there is a speed limit being defined, there is a signal which is being provided, there is, it says that there is going to be a turning. So, lot many things have been used here so as to make the system safe for each and everybody who is going to use it. Then the next factor is the political thought process. Now, when you talk about this political thought process, the reason why we are looking at this is because the final decisions are going to be there from some agency which has the political thought in terms of the development of plans, etc., for any area, city or a region at large. So, when you are talking about this final decision making body, they are going to tell that what type of development is required in a particular area on the basis of the requirements of that area. At the same time, the political things which needs to be implemented in that particular areas, because they have to satisfy their manifesto, etc. Or sometimes they may be looking at the overall development of an area in terms of a scheme, and this is going to bring in the changes in the travel patterns as well as going to make the things eased. So, if that is a scheme which is coming up, then that is also a part of it. So, we are looking at these. So, there may cause a change in the alignment, they may cause that the alignment has to pass through different towns, so that connectivities has to be provided for those. There may be a change in the size of a facility, there may be a change in the type of a facility which to be provided, or the location at which that facility should be provided. They may be done so as to improve upon the traffic conditions in an urban area. So, lot many things are there. I have embedded some examples here that the golden quadrilateral has come up, the north south east west corridor is there, the freight corridors are coming up, there is a scheme named SPMGSY, Pradhan Mantri Gram Sadak Yojana. In the cities, the number of underpasses or flyovers are constructed. They are all part of those thought processes at the top, which has tried to see that what type of connectivity can be provided across the major cities, that means Mumbai, Delhi, Kolkata and Chennai. So, red which you are seeing here, this is nothing but is a golden quadrilateral. When you talk about the green which is connecting Srinagar to Kanyakumari, this is a north south corridor. When you are looking at a Silchar to Porbandar connectivity, it is a east west corridor. The reason that why they are being looked at is so as to provide a faster connectivity across the spaces in the length and breadth of our country. And it is not that only these are there, we have number of state highways, national highways and all those category of roads which are going out of these particular main corridors which have been created. Here you can see the PMGSY road, a very good road which is being providing a connectivity to the remote villages which are there. And this has been extensively taken up all over the country, and it is now in the phase 3, and many of the villages have now been provided the connectivity, and as soon as the connectivity is there, they have also seen the development in their village. So, this is the way the things are going to improve upon in the country. So, with this we can close our interaction today, and we will be talking about the remaining design control factors in the next interaction, and we will see that if we are going to move ahead, then we will take the space requirements for a road in that interaction further. Thank you for now, and bye.